Hello mathematicians and welcome back. Today we're going to be covering exercise 5F, which is finding the equation of a line. I'll get you to open that up in your textbook. Today I'll be running through examples 18, 19 and 20. We did cover this work last year, so some of it should be familiar. You may not be fully confident with you, but hopefully with it, but hopefully with today's work you'll be able to be a little bit more confident and remember what you learned last year. Now there's a couple of slightly different things this year. Finding the gradient, which is what we're going to be doing in here. I mean, that's obviously what it's called. We've done it, well, typically I've shown you how to do that by first drawing it perhaps on a graph and then finding the gradient, which you know is rise over run. Which is pretty straightforward, and that's a second way of doing this one. However, the textbook does talk to us about using an equation. I don't like it so much. I like to be able to draw it and visualize it and know what it means rather than using an equation, but I'll do it both ways. So let's make a start. This is the textbook method here. It uses an equation, and it'll make sense when I write it out. That's supposed to be an m. Let me just go back and write that again. M equals y2 minus y1 on x2 minus x1. Some of you will twig as to what this means. The y's represent, actually over here, I am going to write rise over run. Now m, as you'll recognise from y equals mx plus b, is the gradient. So, and that's why I've written rise over run, which really indicates here that the rise refers to y2 minus y1. I'll explain how that works in a minute. And the run relates to x2 minus x1. Okay? The rise, if you can remember, and let me just draw it for you. I think this is probably the best way of doing it. I'm going to draw these 2 points on a Cartesian plane. So here we go over here. I think if I do both methods at the same time, you'll understand a little bit more what this is about. So the point minus 3, 8 is approximately up here. Okay, I'm going to draw a dot there. The point 5 minus 2 is approximately down here. Okay, and I'm going to join those up with a line. And actually, I should label it, shouldn't I? Or at least, no. I'm going to go, that is minus 3. And it keeps going down, and then it cuts across here to this other point, and that point there is minus 2. Okay, so that's minus 2, where it cuts through the y-axis. Here it cuts through the x-axis there. And then this point up here, if I go across, is 8 high. And if I go up from here, that's your 5. I hope this is not too confusing. I could have just labelled that as 5 minus 2. Yeah, and this top one here is minus 3, 8. I'm just going to draw an arrow, minus 3, 8. The rise, which we have here on the top of the equation, refers to y2 minus y1. And that's exactly what we do when we're looking for this rise here on the graph. If you look, we're taking one of the y values, and we've just arbitrarily chosen y2 as being the second set of points here is minus 2. It could go the other way around. It really doesn't matter which one you use as the second point and which one is the first point. But we're taking the y value from the second point. So that's minus 2. And let me write this down. So that should really be minus 2 or negative 2 minus. And then the y point from the first point. So the y from the first point, so x and y, is 8. So I'm going to write in here that that is 8. Oops, and what am I doing? Let's put an 8 in there. All over, so that's the top line. And we're going to take x2, so that's the x value, which is over here, which is a 5 from point 2. And we're going to subtract the x value from point 1, which is the minus 3, so negative 3. Right. And I'm going to simplify that a little bit further down. So minus 2 minus 8 is minus 10. And 5 subtract minus 3 is 8. And if I simplify that a little bit further, I'm going to pull the minus out the front, is 5 over 4, minus 5 over 4, and that is the gradient. Now, to me, that is the long way of doing it. I'd rather draw it, or at least visualize it in my head, whatever works for you, and go rise over run. And I think it's fairly obvious that the rise, and I'm going to use a different color pen because I can, the rise is this bit here, all right, which is, okay, so I'm going to go rise over run, and the rise I can see goes up to 8 and down to minus 2 is 10. I can see that the rise is 10, a full 10 units, okay? And then the run is a full, and it goes from, and I'll use a different color pen, look at this, is all this way across here. So it goes from minus 3 through to 5, which we can see is 8. Okay, there is one thing here that I've left out, and you've probably picked it already, is this, when we go from this point, maybe I'll choose a different color pen, going from this point through to this point, and we should normally go from left to right, we find that we're not rising, are we? I mean, this point here is not rising, it's going down. So this 10 should have been a minus 10, a negative 10 over 8. And if you can see that that already equals this guy over here. So if I simplify that further, then the gradient equals minus 5 over 4. Now, don't be confused that there are two methods. You use the one that you're comfortable with. I will not impose that you use this equation over here. In fact, I'll be interested to see whether that's on your formula sheet. If it's not on your formula sheet, you might find that difficult to remember. However, you will remember, or you should remember, it's rise over run. A lovely yellow pen, isn't it? And we just need to recognise that this bit here has got a negative, I write it like that, minus VE, slope. And then you can work out the gradient as being the rise over run. I don't think that's all too difficult. Page is rather messy now, isn't it? Okay, find one of those methods that works for you and work with it. Okay, we're going to go to example 19. And example 19 is finding the equation of this particular line that I have over here on the right. All right. Again, we are given 2 points here. What's happening to this? We're given 1 point here and 1 point there, which is sort of similar to the last problem, except we're actually trying to find the whole equation rather than the gradients. Now, the way that we work this one out is simply by finding the gradient. So I'm going to put the standard equation up. So y equals mx plus b. And we will find gradients, we will find the y-intercept, you know those already, and you can put them in, you've got the equation. As simple as that. Okay, let's go. Gradient, you know, is rise over run. So gradient equals rise over run, hopefully this is not too messy, equals, and what's the rise here? You can see that it's a positive slope. So notice that that's a positive slope. You're actually rising from this point through to this point, and the rise value is the y value. Okay, the y value is this second one, so it goes from 1 through to 13. So the total rise there is 12. And the run, you'll be able to see, is from this point here through to over here. So that's the way that it runs. And you'll notice that is the x value. So it goes from 0 through to 4. And in a way, this references that equation that we were using in the last problem. So 12 over 4, and you know that 12 over 4 is 3. So that's our gradient equals m. I'm going to write that down there. Let's put an equal sign there. So m equals 3. Now that we've got our gradients, our y-intercept is pretty straightforward. Y-intercept, and you can see that where it crosses the y-axis is at this point here, which is 1. So equals 1. And now we substitute and it equals the b, just as a reminder for you. Okay, so that's b. We have b of 1, we've got an m of 3. Let's write our equation by substituting in those numbers, and we end up with, I like these coloured pens, y equals 3x plus 1. There we go. Done. That one there was fairly easy. Let me go on to the next problem. It's actually our last problem. This is example 20. This one's probably the most complex of all of the three. But let's make a start. Again, you will notice that we have 2 points. 1 point, 2 points. You have a slope, you've got a line between them. Surely it can't be that difficult. And we essentially tackle this one the same as we tackled the last problem. We just won't get as round a number for this one. The textbook you'll find gives you 2 methods for solving this. We are used to solving it via this first method that we did in the last problem. The other method I could describe to you, and maybe I will. Yes, I will probably have time. You're welcome to follow it, but it's the first method that we're used to using. I reckon stick with something that you know. So let's again start with our standard equation. Y equals mx plus b. Again, sorry for the messiness. Now, let's find gradients. This time I'm just going to write m equals rise over run. And our rise in this particular case, our rise is from this level through to this level. And normally, like I said in that last problem, we like to go from left through to right. So if we're going from left through to right, we find that we're not rising, we're dropping. It's a negative slope to this graph. So in this case, rather than rising from here to here, we're dropping from here to here. Now, our rise value is always the y value because that's our y-axis. It defines how high or how low it is. So our y value here is 11, and then we're going down to 7. When we're going from 11 down to 7, we're moving down 4. So let me write that in there for our rise, -4. And it's over a run of, let's have a look. Our run goes from here through to here. So we're traveling from left through to right, and that again is our x value, just as a reminder. So we're going from 3 through to 6, and we end up with a value of 3. Now, that does mean that we've got some funny looking fraction number here for our gradient. Fear not, is what I'm going to say, despite the fact that I don't like this very much, but it's -4/3 equals m, and I'll just put m there. Now, to find the y-intercept here is a bit tricky because, as we can see, where on earth does this cross the y-axis? No idea. It could be anywhere in there. So there is a different way of doing this one. We're going to substitute in one of these points, and I'm going to choose this particular point into an equation that I'm going to build, and I'm going to show you that in a minute. And then we find a number that makes the equation work. We did this last year as well, so hopefully this is not all too new. So again, starting with y equals mx plus b. No, I'm repeating myself here. I'm going to put the m value in here that we found into the m of this equation. I end up with y equals a -4/3x plus b. Now, I'd said something about substituting in the value from over here, that 6 and the 7, into this equation. So we know that we have a gradient of 4/3. If we put in an x value in here, and from our data point here, it's getting greener and greener, the x value is 6, so I'm going to put 6 in there. And my y value is 7, so I'm going to put 7 in there. Let's rewrite the equation now with those numbers substituted in. 7 equals -4/3 times 6 plus b. That's supposed to be a b, and this here is a 6. Now we want to make this equation true. To do that, we'll simplify this bit in the middle. So I'm going to go 7 equals, what's 4 -4/3 times 6? Well, if you need to, use a calculator. But you know that 4 times 6 is 24. And so I'll write, let me write that. Oh, there's my pen's going all over the place. So it's -24/3 plus b. I'm using a fair bit of space in solving this. I probably don't need to. Tell me, what is -24/3? You should know that that's -8. Now, for this to be true, plus what does b have to be to make this true? 7 equals -8 plus something. Okay, I'm not going to let you think about that too long. It should be 15. Okay, it should be 15. 7 equals minus 8 plus 15. Now, we have discovered what our b value is, and it is 15 over here. So that is our y-intercept. We have our gradient of minus 4 over 3, so we can rewrite this data into an equation that gives us our final equation. So we know our standard formula is this. Let's just put in m and b, and we find that we end up with an equation that is y equals, we already know, minus 4 over 3 plus 15, because we found that our y-intercept was this guy down here. So let's send that in there as well. I've left out my x, haven't I? Let me do some rubbing out. I'll rub out that bit there and rewrite that. Minus 4 over 3x plus 15. And there is the equation for that graph. Now, I did tell you that I was going to show you the different methods. And let's get stuck into that. So I'm going to open up a new page. I'm going to have to redraw. Let me go plus problem. To find the y-intercept, we went through this process here. Is it any smaller? Perhaps a little. And I think that this one is somewhat more intuitive. Okay. I'm going to leave it at that. That is the last of our examples. I would encourage you to do all the left-hand side questions from exercise 5F. Again, feel free to email me. I will not be in class today. Because that's the way it's been arranged for now. So email me anyway, and I'll get to your questions when I can. Thank you very much, and good luck with those questions. Okay, so this is method 2. Method 2, and let's have a look at this. You'll find it is a little shorter, but it's something that we're perhaps not quite so familiar with. So let me draw over here this guy again. We've got our graph as in our straight line there. We do have a point of 311, bear with me. We have a second point here of 6, 7. Not to scale, please. All right, so that's our y-axis, and this is our x-axis over here. So let's have a go at this one. For those of you who are keen, follow along, please. There is an equation, and I've yet to figure out actually whether this one is on our formula sheet as well. Otherwise, you would need to remember it. And it goes like this. I'm going to put it in a special colour because I can. Y minus y1 equals m x minus x1. All right. You can see some familiarity here with x's and y's and m's. The y here will end up being the y in the equation, as in y equals mx plus b. The m will be whatever we find for the gradient. And then the x here, that particular x, is this one that does appear in the y equals mx plus b. This value here for y1 is one that we can choose from over here. So we can choose from this point here. We can place the y value from that data point into, which we know is 11, and we can stick the 11 into this position here where the y1 is. And I can choose the x value, which is a 3 over here from that point, and put it where the x1 is. Now, follow me with this, and so I'm going to put 3 in there, and I'm going to put the 11 in here, and we can form our equation. So let me rewrite it out with those numbers in there. So I'm going to go back to white, because it doesn't, mess with your head. And we get y minus 11 equals, now instead of the m, we already know what our value for the gradient is. We worked that out in the last problem, and it was minus 4 or negative 4 on 3. So I'm going to put that in there for the m. Negative 4 on 3. And then in brackets, I will have x minus 3. Looks a little bit ugly, but we'll make sense out of it yet. What I'm going to do is I'm going to expand this side of the equation. Let's do that first. All right, so on this side of the equation, I've still got y minus 11 equals, now minus 4 over 3 times x, so we multiply whatever's outside of the brackets with the x. We end up with minus 4 over 3x. And then we've got minus 4 over 3, or negative minus 4 over, minus 4 over 3 times a minus 3. A minus times a minus becomes a positive, and then 4 over 3 times the negative, times the 3 becomes 4. Yeah, it becomes 4, believe it or not, plus 4. All right. Now what we're going to do is just collect our number from this side, the negative 11, over to this side, and then we should have our equation. So to do that, I'm going to add 11 to both sides, plus 11, and we find that on this side we're left with the y equals minus 4 over 3x, and 4 plus 11 is 15. And you should recognise that that is exactly the same answer as we got for our last problem. Is that any easier? I think not. Particularly in this method, I'm going to use the blue colour, we had to have worked this out anyway. The minus 4 over 3 we had to work out. So that would be an extra part of this process if we didn't already know it. All right. To find out the value of the y-intercept, we went through this whole process just to get the y-intercept, whereas in the